Good afternoon, everyone. So, what is the geosyncline? This is your first lecture today. So, you may not understand some of the concepts. So, what is a geosyncline? How do you define the geosyncline? A long, narrow, shallow depression with water or without water? With water is known as a geosyncline. Why is geosyncline formed? Due to, no, it is characterized by subsidence. Geosyncline is formed, give me the book, because of folding. There is a folding, anticline. If I still fold it, syncline. So, this is a landmass, this is a geosyncline. They are caused due to folding. What happens in the geosyncline? Initially, there is a deposition of sediments. Sediments deposit होके क्या होता है? In this geosyncline, sediments means broken rock material. So, this are carried by the rivers, deposited in the geosyncline, and उसके कारण geosyncline का depth increases. But over the period of time, it will become shallow. Why it will become shallow? Because sediments आके गिर रहे, and thus there will be full of sediments. So, this stage of a geosyncline, no need of writing, is known as why do we study the geosyncline theory? क्या बताता है geosyncline theory? Formation of mountains, any mountains such as Himalayas. So Himalayas form होने के लिए पानी चाहिए या rock चाहिए? Rock. वो rock कैसे बना? So the rock is first deposited in the narrow shallow sea. इसलिए lithogenesis. Litho is rock. Genesis is origin. फिर the two land masses will come near each other and they will compress those sediments to form mountains, folds, and therefore the second stage will be orogenesis. Oro means mountain. Once the mountain is formed, will the external forces act on the mountain and will it reduce the mountain height of the mountain? So, this stage is genesis, glyptogenesis. Who gave this theory? Weber. Fine. There are two questions in this. One is and second is regarding the Weber's theory and its critical. क्या काम हो गया? कोई और काम नहीं है? And its critical analysis. Right. So first is we have, I guess we have done the definition of a geosyncline. Geosyncline is a narrow shallow depression and it is surrounded by the land masses which are known as forelands. Getting it? So next, geosyncline theory. Those who want to read further, ये theory बहुत अच्छी तरह से दिया है in Savindra Singh. So that is for reference. If you want to read, वैसे our class notes are more than enough for the exam. Fine. Savindra Singh made is 3 pages. You won't be able to write 3 pages in the exam and you will get more confused. Unless I tell you कि books पढ़ना है तो try avoiding the books. First revise the class notes itself only and give the rest of the time to GS. क्योंकि हमें books लगेगी in human geography, हमें books लगेगी in Indian geography, not in this part. चल रहा है. So, the first, that is the geosyncline theory explains the formation of fold mountains. Geosyncline theory explains the formation of fold mountains. explains the formation of fold mountains. This geosyncline, next point, the geosyncline, the concept of geosyncline was first given by, the concept of geosyncline was first given by Hall, H-A-L-L, Hall and Dana. It was first given by Hall and Dana. And it was further developed by Steers. It was further developed by the Steers. So who were the fathers of this? Hall and Dana, and then it was developed by Steers. And theory ultimately किसने दी? Coburn ने. So you should just salute Hall and Dana in the examination and continue forward. Fine. Next. According to Hall and Dana, following are the characteristics of geosyncline. Following are the characteristics of geosyncline. First, these are narrow, shallow water bodies characterized by sedimentation and subsidence. वही जो point हमने first definition में लिखा है, characterized by sedimentation and subsidence. The sedimentation occurs due to the sediments that are brought by the rivers. The sediments that are brought by the rivers originating from the surrounding forelands. FORE, forelands. Third, the forelands are also known as cratogen. The forelands are also known as cratogen. Forelands are also known as cratogen. That is, they are huge land masses, generally made up of igneous and metamorphic rock. Sedimentary rock will not be that much huge, generally made up of igneous and metamorphic rock. And are also known as shield. Igneous and metamorphic rock, and are also known as shield. Why they are known as shield? They are very strong. Shield means in the battlefield you have seen the shield. There is a sword at one hand, the shield at other hand. In Hindi, ढाल. So कौन से word shields है world में? Which one? Brazil is an example of a shield. Canada is an example of a shield. Russia is an example of a shield. Peninsular India is an example of a shield. Remember, jahan we get metallic minerals, that is an example of a shield. Fine? Yes. Is? No. बे ऑफ बंगाल सिर्फ ऊपर से नैरो है और बे ऑफ बंगाल के आसपास बड़े लैंड मासेस नहीं है. इंडिया छोटा लैंड मास है. दे हैव टू बी वेरी वेरी ह्यूज लैंड मास. एंड बे ऑफ बंगाल के लिए जियोसिंक्लाइन होने के लिए इट शुड हैव बीन कंप्रेस्ड फ्रॉम ऑल द साइड्स. नीचे जाते जाते बे ऑफ बंगाल बिकम्स वाइडर. इट शुड हैव बीन लॉन्ग, नैरो एंड शैलो. Yes, it is a geosyncline. It is a perfect geosyncline. Next, the examples of usi point mein the examples of the shield are Russian shield, Russian shield, Brazilian shield, or peninsular India, Fine. So before the laptop, because the laptop is free right now, I'll show you something what you have done yesterday. It will be easy for you to understand. The concept of paleomagnetism.
The other tool used to study plate motion and direction is paleomagnetism, or the record of ancient magnetism recorded in the rocks. To understand how, we first have to review how Earth's magnetic field is produced. We first mentioned it in the lecture on Earth formation. It has existed on Earth.
So why the Earth has a magnetic field? Ye light off kar de. Earth has a magnetic field because of the liquid outer core. And can you see one thing in the video? Our north is actually south of a magnet, and our south is actually the north of a magnet. It's very simple logic. Opposites attract.
So it convects. Because it's a metal, that convection acts very much like a current of electrons moving in a loop, which you'll learn in the basic physics class is one way to produce a magnetic field. Anyone that's ever seen or worked with solenoids can visualize this type of magnetic field. Because of Earth's rotation, the convection currents tend to stack up on each other and combine to strengthen the field. The direction of the field is dictated by the right hand rule. Hold up your right hand, curl your fingers in the direction of the current of the coil of wire, and your thumb will point towards the North Pole of the magnet. Hopefully, you've played enough with magnets to remember. They have two opposite poles, which we call north and south. Try to put the north ends of two magnets together and they'll repel. Let one move freely, and it will rotate so its south end is pointed toward the north end of the other. Earth's magnetic field is oriented pretty closely with its rotational north pole, but not perfectly. And that pole wanders around. Why? The currents change. They speed up, they slow down.
Understanding why the magnetic field is not constant? Because the currents will keep on changing in the direction. So, and this is our north and south, but magnetic north is slightly in the Queen's Island, Canada. Canada ki taraf hai, not towards our geographical north.
They change direction. If you sum up all the currents, subtracting those going in the opposite direction, the net sum gives you the strength and direction of Earth's magnetic field. Does the movement of the North Pole happen fast enough to matter? We can see that the movement has been considerable, and the direction and speed have varied from one year to the next.
Can you see? This is what Wegener said. The continents have changed the direction. So somewhere in 1900, this was the magnetic pole. 2015 में magnetic field has shifted northwards because all the continents are going to the north.
If you grew up in these islands and depended on a need to reset it each year to make sure you knew where it was pointing. As mentioned, the North Pole migrates, but so too do the poles that switch.
We have drawn the same diagram, but we have drawn it horizontally. This diagram is showing vertically. Getting it? Reverse magnetic field, normal magnetic field. हमने भी black white किया था. Have you remember this? We have drawn this diagram, 3 dimension में. Show me the book. Achha, we have not. I have explained you the diagram, but we have not drawn. We have waited till sea floor spreading.
See a pattern? Can we predict a change? Maybe. As these graphs of intensity show, the strength of the magnetic field decreases and then hits zero before either starting up again and increasing in the same direction as before, or increasing but in the opposite direction. What happens during a switch in magnetic polarity? We have no evidence from the fossil or rock world that a switch has ever caused an extinction. There are many organisms that seem to use Earth's magnetic field to help them navigate, but presumably they also use other clues, including visual cues. And since the field decreases and then disappears before flipping, those organisms must rely on their other senses and clues more and more before they lose the field entirely.
Turtles, some of the fishes, some of the birds have compass inside them. They know where is the magnetic field and they will go as per the magnetic field. They will find their directions.
After the flip, they can easily connect the new field back to their clues and use it again, even though it's in the opposite direction. They would simply adjust, as would we. The only major concern would be the increase in solar winds that are normally deflected. The ionized particles would
We have seen this.
the atmosphere as they do now near the poles, creating spectacular auroras. We might see auroras across the planet at all latitudes, and for a while we might see more intense storms. But evidence also suggests that the absence of the magnetic field wouldn't last long enough to produce any major changes. So how do we create these lovely graphs that tell us what Earth's magnetic field direction has been in the past and its strength? We get them by studying fossil evidence left behind in volcanic rocks that erupted on land. As this image of a volcano shows, when lavas erupt, they are molten. As crystals begin to form during cooling, they are free to move. Any magnetic.
So the crystals now are pointing in the direction of the magnetic field. This is what is the paleomagnetism. इससे पहले जो उसने कहा, that is geomagnetism. We have not yet done geomagnetism. Now the answer is paleomagnetism. उससे पहले how the Earth's magnetic field is created, that is geomagnetism.
Minerals that form will rotate to align themselves with Earth's magnetic field. And there's one magnetic mineral that is found in all volcanic rocks. It is called, strangely enough, magnetite.
What is magnetite? Nothing but best quality iron is magnetite.
So we can go to the piles of lavas that make up volcanoes, and starting at the oldest on the bottom, take samples, date them, so we know how old they are, and then measure the direction of their magnetite crystal.
Can you see the direction? It is pointing in one particular direction. छोटे छोटे धागे निकले iron के. That is the direction in which they are pointing.
To see what direction the magnetic field was when they formed. We call that ancient or fossil evidence of Earth's past magnetic field paleomagnetism. This paleomagnetic record becomes a powerful tool for studying plate tectonics when we apply it to seafloor spreading. During World War II in the Pacific Ocean, oceanographers conscripted into the Navy,
This I told you.
combining wartime activities with science and gathering data on seafloor magnetic anomalies. A sensitive magnet towed behind the boat as it crisscrossed the oceans multiple times was able to pick up the magnetism of the pillow basalts under the sediments at the bottom of the ocean. Where the magnet picked up positive anomalies, they registered magnetic fields that were aligned with the present magnetic field, which we call normal polarity, and thus boosted that field, making it stronger. Where the magnet picked up negative anomalies, the pillow basalt magnetites were aligned in the opposite direction, reversed polarity, and were subtracted
Normal,
from the
reverse.
strength of the current field.
ये सब हमें लिखना है. in
By
seafloor
recording
spreading.
these data multiple times as they crossed the mid-ocean ridges, they were able to develop maps such as these, which not only show the dramatic mirror symmetry of seafloor spreading, confirming this essential spreading process, but also
Now what is happening? They have attached a magnet here to the ship. It is getting attracted जहाँ पे negative है, जहाँ पे opposite poles है. It is getting repelled जहाँ पे same है, and that is why the graph is like this.
also can be used to measure spreading speed and direction, as we did with hotspots. How? We have to first find the center of symmetry. This is the center of the ridge. Now we start at the center, where we know the rocks to be the youngest, newest rocks. And as we move outwards from the center, we can correlate each anomaly boundary with the known dates for when Earth's magnetic field has switched. For example, in this image we see that the most recent flip happened about 700,000 years ago. Before that, there was one 900,000 years ago, and another 1.2 million years ago. So back to our anomalies, we can say that rocks along this line must be 700,000 years old, and this one 900,000 years old, and this one 1.2 million years old, and so on. In fact, we can continue this all the way out to the edges of the oceans, and ultimately create an image like this one that shows the age of every rock on the bottom of the sea floor, even though only 1% of the ocean floor has ever actually been sampled.
This diagram we will have to make. Remember.
What an incredibly powerful tool for making indirect measurements and gathering extremely useful information in a most economical way. So, back to measuring speed and direction. Let's use this normal polarity reading that represents 7 million year old rock. Where was this rock when it formed? Here at the spreading center. So what's the direction of plate motion? Away. And how fast on average has it been spreading? If 560 kilometers separates the rock from its origin, then it has traveled 560 kilometers in 7 million years. That's 80 kilometers per million years, or 8 centimeters per year. We call that a half spreading rate, by the way, because it represents how fast.
Why half spreading rate? Because only one half has been calculated. Dusra half will be this side. So total kitna hai speed of whatever the plate they are showing? 16 kilometers per hour. This is how they calculate the speed.
1/2 of the rate is spreading, or how fast the western side is moving away from the center. If we want to know the full spreading rate and how fast both sides are moving away from each other, the distance is doubled, and we get 16 centimeters per year. Pause now.
So this is a good channel if you want to follow. It is known as Earth's Rocks. So you can follow this. And before we go to the last, there is no need of voice here, but still if you want to hear.
How do mountains form? We see them in just a moment of time, but they form over millions of years. Mountain belts extend for hundreds, even thousands of kilometers, and their structures penetrate deep into the earth, so their size and age make their formation difficult to understand. French geologist Jacques Malavier built sand models that mimic the formation of mountains.
Can you see geosyncline?
Belts and allow scientists to study this complex process.
Donc, pour obtenir in order for an experiment that runs for only a few minutes but represents natural phenomena that happen over many tens of millions of years,
This is how experiments are done.
we have to choose a material whose deformation behavior does not depend on time. Le sable est un très bon matériel. Sand is a very good material for simulating rock deformation. In the experiment, the different stratigraphic layers, which represent the sediments and the continental crust, have different mechanical properties. We mix the sand grains with a finer powder, which increases the sand's resistance to deformation. Thus, we have heterogeneous material made up of more resistant layers and less resistant layers.
Mountain belts are created when continents collide. In this experiment, we see two continents separated by an ocean.
sand,
Now watch what happens as the
वो लोग push नहीं कर रहे हैं. Sand, it is made up of sand and sand धीरे धीरे नीचे जा रही है. So what is happening? They are coming near each other. Sedimentation, subsidence, and then orogenesis.
plates converge. As one plate subducts or dives beneath the other, the ocean basin closes. The continental crust, which is lighter than oceanic crust, cannot be subducted. Instead, as the continents collide, the crust thickens and is forced up. Note how the sand is folded and faulted. We see similar structures in the rocks in mountains. One important factor not
The only problem of Kober is he said कि ये region flat रहेगा. What I explained to you yesterday, because the pressure is more here, but that is not the case. You can see even this region is folded.
counter for in this model is erosion. Erosion exposes the deformed rocks that were once
Glyptogenesis. They are talking now about the glyptogenesis.
The green sand represents the rocks of the ocean basin. Note that it's been trapped between the two continents, marking their original boundary. These too we see in mountain belts. It's very difficult to understand the deep structure of a mountain belt by direct observation. The sand model allows us to compress time and space and simulates the internal structure of mountains.
Right? So whenever you do, just look for एक trick है. अगर कोई कुछ भी समझ में नहीं आ रहा है, you should to look at the two things. Avoid the videos that are made in India, because look for the videos either by National Geographic or by any such websites. And thirdly, look for the videos that are short, because short videos will give you a quick animation. Understanding how properly the sand model explains the formation of mountain building, कोई video, कोई computer graphics की ज़रूरत नहीं. You understood how the thick sand, जिसकी density ज़्यादा है, it is pulled, and because it is pulled, they collide. उसके बाद folded, folding के बाद glyptogenesis, that is they will run into the oceans through the rivers, and this is how endogenetic and exogenetic forces will act on each other. Fine. So we stopped in between because the laptop was not available. Russian shield, etc. Next. The geosynclines after the formation, will experience sedimentation, after the formation will experience sedimentation, which increases the load. The geosynclines after the formation will experience sedimentation, which increases the load, and hence the bed of a geosyncline starts subsiding. The bed of a geosyncline starts subsiding, which causes the movement of two rigid land masses towards each other, which causes the movement of two rigid land masses towards each other. Which causes the movement of two rigid land masses towards each other. Draw this diagram. What is this red? Sediments. Exclusive for fold mountains. Fault block mountains नहीं explain हो सकता. Yes. ये तो नेगेटिव है जियोसिंक्लाइन थियरी का. जब हम कोबर का क्रिटिसिज्म लिखेंगे, एल्प्स को एक्सप्लेन कर सकता है, इट कैन एक्सप्लेन एटलस, इट कैन एक्सप्लेन हिमालयास, बट इट कैनॉट एक्सप्लेन टॉकीज एंड एंडीज बिकॉज ऑफ देयर अलाइनमेंट नॉर्थ साउथ डायरेक्शन. एंड उसके आसपास कोई जियोसिंक्लाइन नहीं है. इट इज अ बिग पैसिफिक ओशन. So that is why. So geosyncline theory can explain only east-west mountains, not north-south mountain. कोई भी north-south mountain. ये negative है geosyncline theory का. कुछ नहीं है. आप देखोगे आज के बाद you will realize कि जो भी ये नई theories है, plate tectonic कुछ नहीं, they are improvement over the previous theories. जियोसिंक्लाइन थियरी को फिर और इंप्रूव कर दिया, कॉन्टिनेंटल ड्रिफ्ट को लेके आए, सी फ्लोर स्प्रेडिंग को लेके आए, एंड देन इट इज द प्लेट टेक्टोनिक थियरी. यस, फोर्स इज सेडिमेंटेशन. बीच में का पार्ट नीचे जा रहा है तो ये एक दूसरे के पास खींचे जा रहे हैं. अगेन ये रॉन्ग है. फोर्स इज व्हाट? कन्वेक्शन, नॉट सेडिमेंटेशन. बट ये सिर्फ हिमालयास को अप्लाई होते हैं जियोसिंक्लाइन थियरी. इट कैनॉट एक्सप्लेन एनी अदर माउंटेन्स. ये सिर्फ टेथिस सी को एक्सप्लेन कर सकता है, नॉट एनी अदर माउंटेन्स. अगर डाइवर्जेंट है तो सी फ्लोर स्प्रेडिंग हो जाएगा जियोसिंक्लाइन. यस यस यस, अपोजिट व्यू है. सो दिस इज अ ओल्ड थियरी. इनको तब कन्वेक्शनल करंट्स है, दे वेर नॉट नोइंग दैट ऑल्सो. कन्वेक्शनल करंट केम इन 1930s जब वो एक्सपेरिमेंट किया गया वर्ल्ड वॉर 2 के टाइम. उसके बाद ज्योग्राफी में सब कुछ चेंज हो गया वर्ल्ड वॉर 2 के बाद. उसी को हम कहते हैं क्वांटिटेटिव रिवोल्यूशन. अंडरस्टैंडिंग, जो मैंने फर्स्ट लेक्चर में बताया था. बिकॉज एक्सपेरिमेंट्स वेर डन. क्यों? आई टोल्ड यू हार्वर्ड यूनिवर्सिटी क्लोज ज्योग्राफी एज अ डिपार्टमेंट एंड देन दे हैड टू bring geography back, right? Next point. There are different types of geosyncline. There are different types of geosyncline, such as monogeosyncline. Now if you read geosyncline theory on Wikipedia, on the internet, it starts with the word. This is an obsolete, मतलब rejected theory of mountain building. क्यों? ये it cannot properly explain, but हम क्यों पढ़ते हैं? क्योंकि we have in our syllabus. Understanding? Otherwise world में now this theory is no longer accepted. Monogeosyncline. Mono means single. See, single geosyncline. These are exceptionally long. These are exceptionally long and narrow. Long and narrow. Shallow water bodies. Shallow water bodies. Situated between the continent. situated between the continent or along its borders, or along its borders. Why mono? क्योंकि यहाँ पे दो continents नहीं है, दो land नहीं है, एक ही continent है, and this is located along the continent and its borders. Your doubt yesterday, can we consider Ganga as a geosyncline? अगर consider करते, it would have been a mono geosyncline because it is located only between India. Fine. Not Tethys Sea. Why? Because Tethys Sea was between Gondwana land and Angara land. It was between two different continents. Fine. Iska example. Do we have iska example? Yes. Those who are having atlas, they can see in the map of USA. This is the map of USA, North America. यहाँ पे there are mountains, and these mountains are Appalachian mountains. So Appalachian mountains came out of a mono geosyncline. Example, Appalachian geosyncline. Example is the Appalachian geosyncline. India में कोई example? No need of writing, just I am asking you. India में कोई example which came out of mono geosyncline? Look at the mountains in India. Himalayas? Himalayas? No. Asian plate and Indian plate, alag continent. Aravallis? No. Aravallis was fold mountain proper because ये तब दो अलग अलग continent थे. जो आज राजस्थान है, once upon a time that was different continent, and this side was another continent. But the best Satpuras, Vindhyas नहीं, block mountains है. They are not fold mountains. Geosyncline theory explains the mountains that are caused due to folding. Western Ghats बिल्कुल नहीं. Eastern Ghats, yes. Eastern Ghats are an example of a mono geosyncline. They are ये जो है, this is a mono geosyncline. एक छोटा narrow water body थी in between India, and फिर वो compress हो गई, and this resulted into the formation of Eastern Ghats. So what are Eastern Ghats? Fold mountains, but of a very low height. क्योंकि you have to understand, जितना shallow is a geosyncline, उतना less will be the height. जितना deep is the geosyncline, उतना more will be the height. क्योंकि shallow geosyncline में less sediments, less folding. Deep geosyncline में more sediments, and those more sediments will be folded. ठीक है? Right? Next is polygeosyncline. Polygeosyncline. Again, long and narrow water bodies. Long and narrow water bodies which have more than one phase. Which have more than one phase of mountain building or orogenesis. Which have more than one phase of mountain building or orogenesis. One phase. हिमालयाज में कितने फेज है? 3 फेज है. मिडल हिमालयाज, ग्रेटर हिमालयाज एंड शिवालिक्स. हाउ मेनी रेंजेस ऑफ द हिमालयाज? 3. मतलब 3 बार वो फोल्ड हुआ है. फाइन. सो इट इज नॉट. Himalaya is not a polygeosyncline. Himalayas could have been a polygeosyncline, but Himalayas are more complex than polygeosyncline, and we will call polygeosyncline ka hi more complex as mesogeosyncline. So Himalaya is a mesogeosyncline. ये इसका example is Urals and Rockies. Urals and Rockies. अब somebody asked me, Rocky Mountain को तो explain नहीं करता? Yes, नहीं करता. Theory explain नहीं करती, but classification में है. इसका मतलब किसी ने क्लासिफाई कर दिया, हाँ रॉकीज इज अ मेसो मोनो पॉलीजियोसिंक्लाइन, आस्क हिम मुझे थियरी के साथ समझाओ कैसे बने हैं, दे डोंट हैव एन आंसर. फाइन. थर्ड, मेसोजियोसिंक्लाइन. मेसोजियोसिंक्लाइन, दे आर वेरी लॉन्ग. देखो एडजेक्टिव का डिफरेंस, लॉन्ग एंड शैलो. लॉन्ग एंड शैलो इनसाइड द कॉन्टिनेंट मोनो, outside the continent between two poly. A very long narrow shallow वो हो गया meso. इसका एग्जाम्पल इज टेथिस सी. very long narrow mobile ocean basins. mobile ocean basins which are bordered by the continents from all the sides. Bordered or surrounded by continents from all the sides. And have passed through several phases. Have passed through several phases. Are known as mesogeosyncline. Are known as mesogeosyncline. Example, Himalayas, which came out of Tethys Sea. Alps किससे निकले? Mediterranean Sea is what? Tethys Sea का ही part. So Alps and Himalayas are more or less same. Then फिर Himalayas की height क्यों ज़्यादा है? अगर Alps and Himalayas are both same, where is Alps? Where is Alps? Europe. What is the height of the Alps? Maximum height 6,000 meters. What is the height of the Himalayas? 8,500 kilometers. किसकी height ज़्यादा है? Himalayas की. Which are more dangerous? Climbing, going to Switzerland on Mont Blanc, which is the highest peak of Alps. You go there for tourism. Fine. And Himalaya चढ़ना is adventure. हिमालय माउंट एवरेस्ट को अगर आपको चढ़ना है, इफ यू वांट टू क्लाइंब माउंट एवरेस्ट, एक साल तो आपको फिटनेस ट्रेनिंग होती है. ऐसा नहीं है कि कोई भी उठ के माउंट एवरेस्ट चढ़ जाएगा. देन इफ यू आर फिट इनफ यू कैन गो टू द बेस कैंप. उसके बाद इफ यू सर्वाइव यू विल गो टू द हायर पीक्स ऑफ द माउंटेन. फाइन. सो ऐसा क्यों डिफरेंस है? बिकॉज ये सब जियोसिंक्लाइन थियरी नहीं एक्सप्लेन कर सकती. दिस इज एक्सप्लेन बाय द प्लेट टेक्टोनिक theory. It properly says Alps are ocean continent convergence, Himalayas are continent continent conversion, and because continent continent hai, the height will be greater. Those who have studied GS earlier know what I am saying. Those who have not studied, we will do it. Fine. So don't worry about it. अब Kober's theory of geosyncline. See, ये जो पार्ट अभी तक हमने लिखा है कैरेक्टरिस्टिक्स, सिर्फ ऊपर ऊपर से पढ़ के जाना है. अगर एग्जाम में आया तो ही लिखना है कैरेक्टरिस्टिक्स टाइप्स तक, बट यू शुड नॉट वेस्ट टू मच टाइम ऑन इट. मोस्ट इंपॉर्टेंट इज थियरी, कोबर्स थियरी ऑफ जियोसिंक्लाइन. famous geologist, famous German geologist attempted to explain the origin of mountains through his famous geosynclinal theory. In his book Dar Bao Dar Arde. In his book Dar Bao Dar Arde. RD. German. Spain is like India, कुछ काम नहीं होता, agriculture. It is the German or US. कोई इटली का जियोमॉर्फोलॉजिस्ट नहीं मिलेगा, कोई इसके, एक तो यूएस के मिलेंगे, जापान के मिलेंगे, जर्मनी के मिलेंगे, फ्रांस वाले भी नहीं मिलेंगे क्योंकि फ्रांस वाले कहेंगे नो लिबर्टी फ्रीडम राइट्स, फाइन. सो फ्रांस वाले आपको सब मिलेंगे इकोनॉमिक ज्योग्राफी में. जो रियल साइंटिफिक ज्योग्राफी है उसमें जर्मनी ही मिलेगा या यूएस. यू विल हैव टू राइट द नेम ऑफ द बुक इन द एग्जाम, फाइन. दर बाउ, the mountains, dar arde, the earth, mountains, the earth, the mountains, the earth. Dar in German means the, the. Next, इसने geosyncline को define नहीं किया, so you don't have to define the geosyncline in this. Force. According to Kober, the two rigid land masses move towards each other. The two rigid land masses move towards each other. Q. Subsidence. Don't write. Q subsidence. सेडिमेंटेशन. कोबर कहता है नहीं, सेडिमेंटेशन में इतना फोर्स नहीं है टू कॉज सब्सिडेंस, फाइन. सेडिमेंटेशन बाद में होगा. फॉर सेडिमेंटेशन, फॉर सब्सिडेंस देयर हैज टू बी लार्ज स्केल सेडिमेंटेशन. सो कैसे हुआ सब्सिडेंस, कैसे हुआ मूवमेंट टुवर्ड्स ईच अदर? कोबर सेड it is due to earth was cooling, and because it was cooling it started contracting, and as it started contracting the land masses started moving towards each other. Understanding? कोई भी earth was a rotating ball of fire, उसके बाद वो rotate होते होते cool हो रहा था, and because of cooling what started happening? Contraction. Heating, expansion. Cooling, contraction. Because of contraction the land masses started moving near each other, and as the land masses started moving near each other फिर sedimentation होने लग गया. पहले कॉन्ट्रैक्शन, पहले इतने बड़े लैंड मासेस को मूव करने के लिए सिर्फ सेडिमेंटेशन. अगर ऐसा है सेडिमेंटेशन तो फिर गंगा का ये किनारा और गंगा का ये किनारा एक दिन आके टच हो जाएगा, राइट. गंगा में तो सेडिमेंटेशन इज हैपनिंग, सो दैट मीन्स, और बे ऑफ बंगाल में ब्रह्मपुत्र एंड गंगा आर ब्रिंगिंग लार्ज अमाउंट ऑफ सेडिमेंट्स. सो डज दैट मीन कि इंडिया इज एंड म्यांमार विल टच ईच अदर? नो, देयर हैज टू बी कॉन्ट्रैक्शन, फाइन. फोर्स each other due to contraction caused by cooling of the earth's surface. Contraction caused by the cooling of the earth's surface. Which caused the horizontal movement of the land masses. Right? Second point. According to him, the present day mountains were once mobile zones of water. Present day mountains were once mobile zones of water. Mobile zones of water means geosynclines. दूसरा नाम है जियोसिंक्लाइन. वाई मोबाइल जोन्स ऑफ वाटर? क्योंकि एक जगह रहते नहीं है, वो कॉन्ट्रैक्ट होते, क्रिएट होते. फाइन. मोबाइल जोन्स ऑफ वाटर इज अनदर नेम फॉर जियोसिंक्लाइन. थर्ड पॉइंट, देयर आर 3 स्टेजेस. कौन से 3 स्टेजेस? पहले क्या बनेगा? सेडिमेंट्स. सो लिथो, ओरोजेनेसिस, उसके बाद क्या होंगे माउंटेन्स, ओरोजेनेसिस, एंड उसके बाद माउंटेन्स इरोड हो जाएंगे, ग्लिप्टोजेनेसिस. फाइन, वेरी सिंपल थियरी. See, I guess after वो 4-5 laws, these theories are very easy as compared to them. Fine, Pangea टूट गया, theory खत्म. उसके बाद next theory, interior of the earth was bit difficult, but after that next theory is this, you already know. Yeah, isostasy, uniform density, say different depth and heights, same density, so uniform density, different heights, different densities, uniform depth, khatam. That is Airy and Pratt isostasy. And now the 3 stages. So what was the point I was doing? Fine. Next, there are 3 stages of mountain building. There are 3 stages of mountain building. That is lithogenesis, orogenesis, and glyptogenesis. Lithogenesis, the first stage. First stage, don't write, first stage. This is the first stage in the creation of geosyncline. This is the first stage in the creation of geosyncline, in which the four lands, you already know what is four lands, rigid land masses. उसका दूसरा नाम क्या है, shield. तीसरा नाम क्या है, क्राटोजेन, कुछ भी यूज करो. In which the four lands are subjected to continuous erosion, and this eroded sediments, is deposited in the geosyncline. Eroded sediments are deposited in the geosyncline. उसके बाद क्या होगा, you already know. सब sedimentation के बाद क्या next point होगा, subsidence. Fine. So let's continue in the first stage itself. Due to increasing weight of the sediments, the beds of the geosyncline gradually subside. The beds of the geosyncline gradually subside. This combination of sedimentation and subsidence results into deposition of huge volume of sediments. And draw the same diagram we had drawn just earlier. देखो the way I am drawing. Give me a minute. See, two things. That is, ek to you will get your ID card today, and secondly is tomorrow we are keeping the class. वो भी मैं पूछने गया था because we had skipped one class, so tomorrow you are having a optional का class at 2:30. कितने बजे? 2:30. So I'll send you a mail accordingly, कुछ adjust हो सकता है तो. So you can take down. Second stage. वही डायग्राम बनाना है, मतलब उसमें एरोज दिखाने हैं. Stage, have you finished drawing this? Stage 2. ओरोजेनेसिस और स्टेज 2. ओरोजेनेसिस, इसमें क्या लिखोगे? Subsidence के कारण the mountains are coming near each other. Due to this, there is a squeezing of the sediments resulting into formation of mountains. That is the stage 2. Stage 2 orogenesis is related to the building of mountains. Is related to the building of mountains. The two forelands start to move towards each other. The two forelands start to move towards each other due to contraction resulting from cooling. Due to contraction resulting from cooling, as well as due to sedimentation. As well as due to sedimentation. As well as due to sedimentation. Due to squeezing of the sediments. Due to the squeezing of the sediments. कहाँ पे squeezing होगा? Along the sides. कोबर क्या कहता है? Due to the squeezing of the sediments, he says marginal mountains, that is mountains will be formed along the sides. Marginal mountains are formed. Marginal mountains are formed on the sides of the geosyncline. On the sides of the geosyncline. Sides of the geosyncline. Termed by Kober as Rand-Ketten. Termed by Kober as Rand-Ketten. Termed by Kober as Rand-Ketten. Rand-Ketten मतलब mountains along the sides. Fine. If the intensity of the compressive forces, if the intensity of the compressive forces इसमें हाँ या शिवालिक्स, if the intensity of the compressive forces are not strong, the middle portion of the geosyncline is unaffected. Understanding? कल जो मैंने कहा why Tibetan plateau, क्योंकि pushing is not strong, so middle portion of the geosyncline is unaffected and thus remains unfolded. Thus remains unfolded. This unfolded part was termed by Kober as Zwischenbergi. Was termed by Kober as Zwischenbergi. Zwischenberge. BIR. चलो don't write Zwischenbergi or median mass, बीच में का पोर्शन, मीडियन बीच में का मास. क्यों? Because the compressive forces are not that great enough कि बीच में के पार्ट को it is going to affect. But हमने अभी एक्सपेरिमेंट ने देखा कि बीच में का पार्ट तो पहले फोल्ड हो जाता है, फाइन। सो ये एक नेगेटिव पॉइंट है इसका, बट नेगेटिव होने के बाद भी दिस इज द ओनली रीजन विच एक्सप्लेन्स टिबेटियन प्लाटू। एग्जाम्पल, फॉर्मेशन ऑफ टिबेटियन प्लाटू। Example, the formation of Tibetan plateau. If the force is greater, if the force is greater, then the entire region may be folded. If the force is greater, then the entire region may be folded. Entire region may be folded. So, diagram. See, the diagram has changed. We have just seen in the video कि entire mountain is folded. ऐसे नहीं कि only upper part is folded. That is what we have showing in this. Folding मतलब क्या? Squeeze कर रहा है वो to the sediments that were formed. What is the center part in this next diagram? The Tibetan plateau lying between the Kunlun Shan, Ten Shan, Altai Shan, China का and the Himalayas, India का. नहीं, ज़्यादा बनाई है. कुल्लू की हाइट मिडल हिमालय जितनी है, ग्रेट हिमालय से ऑब्वियसली कम है. Stage 3, Glyptogenesis. Gliptogenesis. Genesis. Glyptogenesis. क्या होगा इसमें? Once the mountains are formed, they will be eroded by external forces, and thus the height of the mountain will keep on decreasing. This is what is the third stage. In the third stage, the mountains are characterized initially by gradual rise, पहले उनकी हाइट बढ़ेगी धीरे, by gradual rise, and then later by continuous lowering of the heights, due to the forces of denudation. Fine. Such as rivers, glaciers, etc. Khatam theory. That is what is the theory says. So diagram for third one. कुछ नहीं, सेकंड वाले डायग्राम को थोड़ा लो बनाना. नीचे एग्जैक्टली सेम दिखाने की जरूरत नहीं है, बिकॉज नीचे के सेडिमेंट्स वोंट बी फोल्डेड दैट मच. Which one? Which one? The ranges. Denudation, the forces of denudation will cause lowering of the height. This one you are saying. This is folding which is going deep inside there. This is not the height. It is not going to go down. Height will be this only. This is how inside the earth rocks will be folded. You don't, this is not the height, it is not subsidence. और क्या मेजर डिफरेंस है? एरोज हट जाएंगे, बिकॉज एरोज अगर दिखाए मीन्स माउंटेन विल कीप ऑन राइजिंग, एरोज हट जाएंगे. His doubt was why the mountain is going down. It is not going down. This is the fold that is occurring inside the ground. Mountain is this much only. पहले इसमें it was of a greater height. Now उनका height has reduced. Fine. No diagrams. No arrows. Land masses are no longer moving towards each other. अगर लैंड मास मूव टुवर्ड्स ईच अदर तो कंप्रेशन होगा एंड हाइट विल इंक्रीज. That is the theory. Thus this theory explains the mountain building. Now tell me critical evaluation of this theory. Why do you agree with Kober या कुछ faults लग रहे हैं? Tell me the faults. सविंद्र सिंह के मत बताना मुझे, बुक्स के मत बताना. टेल मी समथिंग डिफरेंट. कौन सा? कि सबसे पहले यस देखो कॉन्ट्रैक्शन वाला पॉइंट विल राइट इट ऑब्वियसली फर्स्ट बिकॉज इट इज मेंशन इन द बुक, बट द मोस्ट इंपॉर्टेंट इज कि it does not explain why there is lowering of the mountains. Sometimes height of the mountains decreases in spite Indian plate and Asian plate moving towards each other. ये एक दिमाग में रखो. Secondly, जरूरी नहीं कि each and every mountain came out of the geosyncline or the sea, because geosyncline has to be long, narrow and shallow, but Rockies and Andes के western side में there is Pacific Ocean which is neither long but extremely wide, not shallow. Obviously it is one of the deepest, it is the deepest ocean of the world, not one of the, it is the deepest ocean of the world. So how do you explain Andes and Rockies? This theory has no answer. It can explain only Alps and Himalayas. Fine. Third, Aravallis को कैसे explain करोगे? It has no answer. Fine. Urals को कैसे explain करोगे? It has no answer. What about the mountains that are located inside? In fact, forget Himalayas and this thing. Studies have shown that Himalayas are younger and Kunlun are older. अगर geosyncline में, in the geosyncline theory, if both the land masses are colliding at the same time, then why one mountain is older and why one is younger? Fine. So these are some of the faults of the geosyncline theory. But obviously, book wise, the first point, scientists agree or geographers agree, don't write scientists, geographers agree that contraction is not a proper force, to explain the formation of very extensive is not a proper force to explain the formation of very extensive mountains such as Himalayas. In fact, the plate tectonic theory has properly explained that such mountains are formed due to collision of two plates, collision of plates due to hot convective currents coming from the asthenosphere. due to hot convective currents coming from the asthenosphere and not due to cooling and contraction. And not due to cooling and contraction. Not due to cooling and contraction. कन्वेक्शनल करंट इसके बाद का ही टॉपिक है, सो यू विल अंडरस्टैंड दिस पॉइंट. मतलब कूलिंग से तो रिलेटेड ही नहीं है माउंटेन बिल्डिंग. माउंटेन बिल्डिंग इज रिलेटेड टू हीट दैट इज प्रेजेंट इनसाइड द अर्थ. एक जनरल पॉइंट याद रखो. सेकंड, studies have shown that कौन मूव कर रहा है? As per geosyncline theory, India and Asia is moving towards each other, but paleomagnetic evidence, computer models shows what? Only India is moving, Asia is constant. Fine. So studies have shown that only one part moves, one part of the landmass moves, one part of the landmass moves, while the other part remains stable. Other part remains stable. Other part remains stable, which is in contradiction with the geosyncline theory. Which is in contradiction with the geosyncline theory. In which both the land masses to move towards each other. In which both the land masses move towards each other. Same point, next paragraph. Okay. हम एग्जाम्पल लिखेंगे. See, ये point ही both the land masses do not move towards each other, only one land mass moves towards each other, was first given by Sir Edward Suez, जिसने concept दिया था Cial, Sima and Nife का. So Sir Edward Suez said, you know, Kober is wrong because only one land mass moves towards each other. एक land mass stable होगा, he called that as a backland. One land mass which was moving towards the geosyncline was known as a foreland. उसने थोड़ी change की थी ये theory. हमारे सिलेबस में नहीं है, हम ये सब नहीं लिखेंगे, बट मैं सुएज का नाम इसलिए ले रहा हूँ. आई एम टेकिंग द नेम ऑफ सुएज. ही सेड दैट हिमालयाज वेर फॉर्म्ड ड्यू टू साउथवर्ड मूवमेंट ऑफ अंगारा लैंड. यू नो, हिमालयाज वेर फॉर्म्ड ड्यू टू द नॉर्थवर्ड मूवमेंट ऑफ गोंडवाना लैंड, नॉट ड्यू टू द साउथवर्ड मूवमेंट ऑफ अंगारा लैंड. सो एग्जाम्पल प्लेट टेक्टोनिक्स have shown, plate tectonics comma paleomagnetism has shown enough evidences of sea floor spreading in the Indian Ocean, and northward movement of Indian plate, causing formation of the Himalayas. Indian plate causing formation of Himalayas. इंडिया किसके तरफ मूव हुआ? नॉर्थ की तरफ, causing formation of the Himalayas. Point number 3, वो जो it is very common. The geosyncline theory satisfactorily explains east-west mountains such as Atlas, sorry, Alps, don't write Atlas, Atlas बहुत minimal mountain है. Alps and Himalayas, Alps and Himalayas, but cannot explain, huge north-south mountains, such as Andes and Rockies, which face the Pacific Ocean, which face or which are near on the coast of Pacific Ocean, and not near any geosyncline, which face the Pacific Ocean and not near any geosyncline. What is the definition of geosyncline? Long, narrow, shallow. Pacific Ocean इसमें से कोई भी क्राइटेरिया ये करता है, हाँ लॉन्ग हुआ है बट नैरो तो बिल्कुल नहीं है एंड शैलो भी बिल्कुल नहीं. व्हाट वाज योर डाउट? अभी हमने सी फ्लोर स्प्रेडिंग का वो प्लेट टेक्टोनिक्स नहीं देखा है. सो वहाँ पे सी फ्लोर स्प्रेडिंग के कारण नॉर्थ एंड साउथ अमेरिका इज मूविंग वेस्टवर्ड्स, बट जो दूसरा है रिज सी फ्लोर स्प्रेडिंग का, वो ऐसे जाते हुए अफ्रीका के नीचे से सी फ्लोर स्प्रेड हो रहा है. तो सी फ्लोर स्प्रेडिंग है, इफ वी लुक एट द डायग्राम ऑफ द सी फ्लोर स्प्रेडिंग, अफ्रीका, so the sea floor spreading is occurring somewhat like this. Getting it? So किस तरफ जा रहा है इंडिया एंड अफ्रीका? नॉर्थ की तरफ. इसके ऊपर का पार्ट इज गोइंग टू द नॉर्थ. ऑब्वियसली अफ्रीका कैसे जा रहा है? नॉर्थ ईस्ट, हाँ नॉर्थ ईस्ट की तरफ. इंडिया कैसे जा रहा है? नॉर्थ ईस्ट की तरफ. एग्जैक्टली नॉर्थ नहीं, नॉर्थ ईस्ट. फाइन. आई हैव अंडरस्टूड द 3 क्रिटिकल एनालिसिस. रटने की जरूरत नहीं है जियोसिंक्लाइन जैसी थियरीज. रिमेंबर दे आर ऑल वेरी लॉजिकल. फाइन. सो कैन यू रीड दिस ईयर्स क्वेश्चन? (2018). So take down the question this year. Evaluate how far Kober's geosyncline theory explains the mountain building process. How far Kober's geosyncline theory explains the mountain building process. Fine. So tell me what you are going to write here. Evaluate. पहले कैसा होगा इसका अप्रोच? डेफिनेशन ऑफ अ जियोसिंक्लाइन, कोबर की थियरी की 3 स्टेजेस, कैरेक्टरिस्टिक्स लिखने की जरूरत नहीं, उसके क्रिटिसिज्म्स जो हमने लिखे, और उसके बाद कंक्लूजन. तो मैं आपको पूछ रहा हूं इसके लिए कंक्लूजन क्या होगा? आंसर इज वेरी डायरेक्ट. हिमालयस का फॉर्मेशन एक्सप्लेन कर रहा है ये थियरी. हाइट क्यों है ज्यादा हिमालयस की? वो कहाँ एक्सप्लेन कर रहा है फॉर्मेशन ऑफ हिमालयस? तो वही क्या है क्रिटिकल एनालिसिस? थोड़ा सोचो, ये थियरी ने ट्राई किया एक्सप्लेन करने को माउंटेन बिल्डिंग, बट it satisfactorily tried to explain formation of some limited aspect. बेस्ट क्या है इस थियरी का कि हाँ थोड़ा बहुत आइडिया दिया हिमालय के बारे में, थोड़ा इंसाइट दिया, बट सच थियरीज हैव नाउ बिकम ऑब्सोलीट ड्यू टू प्लेट टेक्टोनिक थियरी. फाइन, डायरेक्ट ऐसा नेगेटिव मत लिखो कि ये बकवास थियरी है, रिजेक्ट कर दिया. फाइन, थोड़ी लैंग्वेज अच्छी रखो. यस, डायग्राम्स तो जरूर ड्रॉ करना. स्पेस कम नहीं पड़ेगा. 250 वर्ड्स का क्वेश्चन है. कितने? 20 मार्क्स का है ना. 20 मार्क्स मीन्स 250 वर्ड्स. कम नहीं पड़ेगा. 3 पेजेस मिलेंगे तुम्हें. सो व्हाट इज जियोसिंक्लाइन थियरी? जो अजरुद्दीन या जो अभी पाकिस्तानी टीम बोलती है, बॉयज प्लेड वेल, वी ट्राइड आवर बेस्ट but we lost. So he tried his best to explain the mountain building, but he could not explain anything. Right? So conclusion, that is why I have not given the conclusion. ताकि conclusion कहाँ जरूरत पड़ेगा? किसी भी आंसर में लिखो. पूछा है नहीं पूछा है क्रिटिकल एनालिसिस, फिर भी लिखो conclusion. ज्योग्राफी में इतना फर्क नहीं पड़ता. क्रिटिकल एनालिसिस, इवैल्यूएट, वो सब एक ही है ज्योग्राफी में. फाइन. conclusion, Kober's theory satisfactorily explains only few aspects of mountain building. But suffers from weaknesses in the terms of force and limited applicability and limited application. In the terms of force and limited application. Thus, Kober can be given credit for advancing the idea of geosynclines. See, plate tectonics भी कहता है it came out of the Tethys Sea, but process अलग है. But it also advancing the idea of geosyncline, which is then properly explained in plate tectonic theory. Properly explained in the plate tectonic theory. Plate tectonic theory. Fine. So that is the best. See, हम reject ही कर रहे इस theory को, कितने प्यार से कर रहे. Getting it? So that is the idea of answer writing, nothing else. अब इसमें से when you write on your own, you will skip some words. You will write a conclusion का 2-3 lines also कि it gives an idea which was later on developed by plate tectonics. So that is your choice. But ऐसा एक structure होने दो. Fine. Now second thing is what he said yesterday, and you also must be knowing, because in geography there are 2 lobbies in UPSC. One is the follower of Delhi school, one is the follower of Allahabad school. Fine. And ये दोनों एक दूसरे के एकदम क्रॉस में. फाइन. सो इलाहाबाद स्कूल वाले आंसर अगर देखते हैं और अगर दिल्ली स्कूल वाले का आंसर है, तो मार्क्स नहीं मिलते. दो अनफॉर्चुनेटली सच थिंग शुड नॉट हैपन, बट सविंद्र सिंह के फॉलोअर्स नहीं मिलेंगे डीयू में, एंड डीयू के फॉलोअर्स नहीं मिलेंगे इलाहाबाद यूनिवर्सिटी में. डू वी हैव इन डीयू ज्योग्राफी? यस. Geography, sociology and economics are the three subjects that are taught in Delhi School of Economics. Fine. So how to come out of such problems? You would never know किसके पास पेपर जाएगा. The best is जितना you are strong in paper 1 physical geography, उतना better will be the marks. Fine. क्योंकि पेपर 1 फिजिकल ज्योग्राफी, जियोमॉर्फो, क्लाइमेट, ओशनो में इसमें कोई स्कूल है नहीं. उसमें एक ही स्कूल है, प्लेट टेक्टोनिक्स. फाइन. उसमें एक ही स्कूल है, फिजिकल ज्योग्राफी की स्कूल. चाहे इट इज सविंद्र सिंह, चाहे इट इज माजिद हुसैन, चाहे इट इज एवरीवन विल बी सेइंग द सेम थिंग्स. गेटिंग इट? बिकॉज इट इज जो है वो है. इट इज नॉट लाइक ह्यूमन ज्योग्राफी. ह्यूमन ज्योग्राफी इज ह्यूमैनिटीज, आर्ट्स. आर्ट्स में ये भी राइट है, ये भी राइट है, ये भी राइट है. देखने का नजरिया है, द व्यू व्हाट यू गेट. Right? Determinism is also right, possibilism is also right, and neo-determinism is also right, welfareism is also right. मतलब determinism कहता है physical geography पढ़ो, the possibilism says human geography पढ़ो, neo-determinism says दोनों का mix पढ़ो, welfareism says कुछ मत पढ़ो, लोगों के welfare के बारे में policies बनाओ. All are right. Fine. And उसलिए the people who, I told you women in the first lecture, people who generally depend on human geography in optional, कि वहां से ज्यादा क्वेश्चन हम उठाएंगे सेक्शन बी में से, जनरली उनके मार्क्स एक तो डायरेक्ट टॉपर आएगा वो, या फिर सिलेक्शन ही नहीं मिलेगा. फ्लक्चुएट बहुत करेंगे. डिपेंड्स अपॉन आपने किसका व्यू लिखा है. माजिद हुसैन का लिखा है दिल्ली स्कूल ऑफ, या सुदीप्ता अधिकारी का लिखा है इलाहाबाद स्कूल. गेटिंग इट? या और एक बुक है, व्हाट इज द नेम ऑफ द थर्ड बुक? आई टेल. आर.डी. दीक्षित का लिखा है जयपुर स्कूल. फाइन. सो द बेस्ट. ये किस में होता है? ये सब सब्जेक्ट्स में होता है. इवन इन पॉल साइंस दिस ऑकर्स, इवन इन पब्लिक एडमिनिस्ट्रेशन दिस ऑकर्स. ज्योग्राफी, हिस्ट्री में इसका स्कोप लिमिटेड है, बिकॉज थिंग्स आर लिमिटेड. सो पॉल साइंस में जब तक लॉबी हियर इन यूपीएससी इज ऑफ दिल्ली या पब्लिक एडमिनिस्ट्रेशन में, इट विल गिव गुड मार्क्स. लेट इट गो टू पुणे यूनिवर्सिटी, जहाँ पे पूरे लेफ्टिस्ट बैठे हैं, गोखले इंस्टीट्यूट में, या पूरे अलग लॉबी बैठी है, मार्क्स सडनली डाउन हो जाते हैं. पब्लिक एडमिनिस्ट्रेशन सफर्ड बिकॉज ऑफ दिस रीजन ओनली. सो देयर वाज अ फेमस, सुहास पलशीकर इज द फेमस प्रोफेसर इन महाराष्ट्र. व्हेन ही सेट द पवाड का पेपर फ्रॉम 2012, 13, 14, 15, टॉपर्स छोड़ो, पीपल गॉट आउट ऑफ 600 120 मार्क्स, 130 मार्क्स. मार्क्स ही नहीं आते थे. यस. तो गाइडलाइंस आर गिवन बाय द पेपर सेटर. मीन्स दे यूज्ड टू सेट सो डिफिकल्ट क्वेश्चंस कि आपको उसका किसी बुक्स में मिलेगा ही नहीं. क्वेश्चंस डालो 2012 का, एंड लुक एट वो लैंग्वेज. गूगल दिखाएगा कौन से बुक से लैंग्वेज है. एक भी इंडियन ऑथर नहीं, वो रशियन ऑथर्स की लैंग्वेज है. पॉसिबल है क्या एक साल में कोई लड़का, या 2 साल में, 5 साल में आप 3-4 बुक्स पढ़ोगे मैक्सिमम. रशियन ऑथर को पढ़ोगे आप? इम्पॉसिबल. राइट? सो द बेस्ट इज टेक दिस थियरीज. दैट इज द क्वेश्चन नंबर 2 and 3 आपका बहुत स्ट्रांग होना चाहिए. एंड देन यू शुड टेक ओनली वन क्वेश्चन, क्वेश्चन नंबर 8 या क्वेश्चन नंबर 5, क्योंकि ह्यूमन ज्योग्राफी में फर्स्ट चैप्टर, दैट इज चैप्टर नंबर 5, एंड लास्ट थियरीज, वो भी ऑब्जेक्टिव है. देयर इज नो सब्जेक्टिविटी इन इट. गेटिंग इट? Not given in our syllabus, never asked, but we do this to understand the further theories. This may be asked because this is also a part of formation of the earth's crust. जो point है आप, This came last year in GS as mantle plume. कुछ नहीं है, यही आंसर है. If you read the past year GS का paper, what is the mantle plume? Explain its role in plate tectonics. Mantle plume is nothing but the convectional current theory of Arthur Holmes. This is the earth, the crust where we are staying. Fine. So we know now that earth is divided into different plates, and these plates are made up of lithosphere. देखो, right from this theory, अब हम छोड़ रहे सियाल and सीमा. We are going to come to lithosphere. Lithosphere is a solid crust. It is divided into two parts, continental and oceanic. Lithosphere is crust plus some part of a mantle, uppermost part of a mantle. Lithosphere के नीचे, as the temperature increases, there is asthenosphere, and in the asthenosphere the temperature is so high that convectional currents are generated. What is convectional current? When you heat anything, there is a vertical rise of the molecules, and this is what is known as convection. If there is too much heat in the summer season, तो एक दिन on the ground हवा ऐसे आंधी आती है. This is what is the convection. Anything, when you put chai in the morning, chai ubal aati hai, that is convection. दूध उबर आता है, or anything when it is boiling, that is convection. Convection is vertical transfer of the heat, because warm becomes less denser and it starts rising upwards. Fine. So inside the earth there is asthenosphere, and inside the asthenosphere there is high heat, 2000 to 6000 degrees Celsius. It will vary from place to place, and therefore inside the earth, when in the asthenosphere, convectional currents are generated. This convectional currents sometimes rise upwards. Fine. As they reach near the crust यहाँ पे तो मैंने ब्रेक किया है, but it is same. Getting it? Broken नहीं है. Initial इसमें it was not broken. हमें diagram में ऐसे बनाना है. It is the same. So they are stopped by the crust, and because of the stopping of the crust, they get diverted into different parts. Fine. Because there is a continuous divergence of the convectional currents, if the crust is below the oceans, we know the oceanic crust is 0 to 5 kilometers thick, that means uska thickness is very, very less. So the oceanic crust is stretched because convectional currents are very strong, as the thickness of that asthenosphere is 200 kilometers. So 200 kilometers में से वो पूरा convectional currents are coming, while the thickness of the crust is only 4 to 5 kilometers. मैंने आपको ही पूछा था in this class, if you cover vessel with lead, and if there is a vapor coming out, the vapor, does it have power to displace the lead? Yes, the same thing is happening. So convectional currents will stretch the crust, and ultimately the crust will be broken into two parts, and this, after breaking into two parts, the plates will move in opposite direction, जिसको हम कहेंगे divergence. So this part of the crust gets diverted. But कितने convectional currents है, क्या है? There are large number of convectional currents. ऐसे नहीं कि अर्थ में एक ही डायरेक्शन में चल रहा है. Numerous convectional currents are generated. आपका दूध सिर्फ एक पॉइंट से नहीं उबलता. Numerous bubbles are created. Fine. So similarly, inside the earth there are numerous convectional currents. So these convectional currents will go in different direction. There can be one convectional current which is coming from here, and this is the region. This is how the earth is. Now this crust, see, I am making it different because this crust is an example of or I will make the simple diagram. This crust is an example of continental crust. Which is lighter, Sial or Sima? Sima is, which is lighter? Sial is lighter. So there can be another convectional current inside which is going upwards and it is coming in this direction. Now यहाँ पे what is happening, both the convectional currents are colliding and after collision उनका density will increase because दोनों के पास material है, convectional current नहीं, उसके साथ साथ water vapor, gases etc are going and because of increase in the density वो नीचे की तरफ आएंगे. So inside the earth there are numerous cells of the convectional currents which will diverge at certain point and which will converge at certain point, and due to this what we find is the plates are constantly in motion and therefore the continents and the ocean basins will move from one place to another, not due to contraction, not due to tidal force, but these are formed due to the convectional currents. जहाँ पे the convectional currents meet each other, there is convergence. And जहाँ पे convergence होगा, there will be formation of the fold mountains. So this is the reason responsible for movement of the continents, movement of the plates. ये सब बाद में किसने बताया? Arthur Holmes ने. And this is the convectional current theory. What did Wegener say? Tidal force. No tidal force. What did Kober say? Contraction. No contraction. It is because of the heated asthenosphere that is the convectional currents are generated and their direction is not constant and therefore creation and destruction keeps on happening. So you can draw this diagram. जहाँ पे Sial is colliding with Sima, जो ज़्यादा denser है, it is going to go below. जो less denser है, it is going to stay at the top. So generally the oceanic plate goes below and the continental plate stays at the top. When it goes below for more than 80 kilometers, it will melt. Remember the isostasy theory. 80 kilometers के बाद heat is very high and it will again become a part of or you can write anything. What is this? What you want to write? Magma लिखो या asthenosphere लिखो. Understanding this, convectional currents are generated due to heat. They will move in different direction. जहाँ पे they will go in opposite direction, वहाँ पे plate फटेगी, sea floor spreading होगा. क्यों हमेशा sea floor spreading? Why never continent spreading? Because thickness. Sea floor में thickness less है, so इसलिए crust easily टूट जाता है. Continents में thickness great है, इसलिए वो टूटता नहीं है. कोर, बट कोर के ऊपर क्या है? मेंटल है जो सॉलिड है और जिसकी थिकनेस इज फ्रॉम 400 किलोमीटर टिल 2900 किलोमीटर. तो इतना ज्यादा थिक है, उसको कैसे तोड़ेगा? किसको तोड़ रहा है वो? वहां पे भी कन्वेक्शनल करंट है बट वो हमें इफेक्ट नहीं कर रहा है. किसको तोड़ रहा है वो? ओशियनिक क्रस्ट को. क्यों तोड़ रहा है ओशियनिक क्रस्ट को? क्योंकि वो थिन है. कन्वेक्शनल करंट्स तो हिमालयस के नीचे भी है, बट इसका मतलब ये नहीं कि इंडिया को तोड़ेगा वो सी फ्लोर को ही तोड़ सकता है, बिकॉज कॉन्टिनेंटल क्रस्ट इज थिक, थिकनेस ज्यादा है. इमेजिन करो कि आपने उस वेसल के ऊपर पतला ढक्कन रखने के बदले मोटा ढक्कन रख दिया, उसको नहीं हिला पाएगा। Convection is only due to heat. Convection inside the asthenosphere, plate tectonics. Convection on the land, thunderstorms, tornado. Convection on the water body, cyclones. सब कुछ तो convection ही है, सब कुछ heat है. Heat is a form of energy. Convection at equator, ITCZ. Now the heat, maximum heat is over India. So convection, monsoons. सबके लिए responsible is heat as a form of energy. So अपने सविंद्र सिंह के चैप्टर में से इफ यू आर रीडिंग जस्ट डू जियोसिंक्लाइन, उसके बाद स्लाइडिंग कॉन्टिनेंट थियरी डैली की है, जॉली की थियरी, वो सब नहीं करनी है, वो सब नहीं है अपने सिलेबस में. फाइन, सिर्फ 4 पेजेस करने हैं चैप्टर में से, दैट इज द जियोसिंक्लाइन थियरी के. उसकी भी जरूरत नहीं बिकॉज वो थोड़ा कॉम्प्लेक्स वे में दिया है. कौन सा? हाँ, नहीं, दोनों का ऊपर है. कन्वेक्शन करंट कैसे है? कन्वेयर बेल्ट जैसे ओशन में ऐसे घूमते रहेंगे. सो जो ऊपर जा रहा है वो नीचे आ रहा है. तुमने ग्रेजुएशन में ट्रेड विंड्स पढ़ी, ट्रेड विंड्स नीचे ऐसे जाती है ईस्ट टू वेस्ट. फाइन, ऊपर जाके उल्टा ही तो जाती है वो भी तो एक कन्वेक्शन है. एयरपोर्ट पे लगेज का बेल्ट, वो भी तो कन्वेक्शन है. नहीं, काउंटर नहीं, ये जो ऊपर जाएगा, ऊपर जाके थोड़ा ठंडा होगा, वो डेंस हो जाएगा, इसलिए वो नीचे आएगा, फिर से नीचे आके गर्म हो जाएगा. मैग्मा में ऐसे घूमता रहेगा वो. अगर इफ यू हैव ग्लास का एनी वेसल, ट्राई बॉइलिंग अ वाटर, सेम दिखेगा आपको. दिस इज हाउ कन्वेक्शन करंट इज जनरेटेड. दे विल ऑलवेज गो इन अ सर्कुलर मैनर. फाइन. अब नथिंग, सी एवरीथिंग, इस थियरी ने सारे प्रॉब्लम सॉल्व कर दिए. व्हेन डिड वेगनर्स कॉन्टिनेंटल ड्रिफ्ट थियरी केम? 1912. व्हेन डिड ये आइसोस्टेसिका केम? 1860s. व्हेन डिड जियोसिंक्लाइन केम? अगेन इन 1860s. व्हेन डिड कन्वेक्शनल करंट थियरी कम? केम 1928. सो 1928 में फिर हैरी हेस ने कहा, उसी का, डोंट ड्रॉ दैट इन द डायग्राम, मैं जो अभी बनाने जा रहा हूँ, उसको ये पता चल गया. अब उसने थोड़ा दिमाग लगाया, उसने कहा अब एक बार क्रैक, वंस इट इज फॉर्म्ड, इसमें से मैग्मा विल कम अप, देन इट विल सॉलिडिफाई, and thus there will be mid oceanic ridges, and we will call this as a sea floor spreading theory. 1940s. फिर कन्वेक्शनल करंट थियरी को ही कंप्यूटर 2-3-8 साइंटिस्ट ने पढ़ा, और कहा कन्वर्जेंट प्लेट बाउंड्री, फोल्ड माउंटेन्स, डाइवर्जेंट प्लेट बाउंड्री, मिड ओशियनिक रीजेस. फाइन. कन्वर्जेंट प्लेट बाउंड्री, ट्रेंचेस, प्लेट टेक्टोनिक थियरी. सो प्लेट टेक्टोनिक थियरी, क्योंकि इन सब थियरी रुकी हुई क्यों थी? क्यों प्लेट्स आर मूविंग? व्हाट आर द फोर्सेस रिस्पॉन्सिबल फॉर ड्रिफ्ट? यही नहीं समझ में आ रहा था. वंस आर्थर होम सेड कि ये है फोर्स रिस्पॉन्सिबल फॉर ड्रिफ्ट, उनका प्रॉब्लम सॉल्व. नाउ दे कैन गिव एनी ऑफ द थियरी. फाइन. What is the importance of the convectional current theory? Gave the force that is responsible for the drifting of the continents. It is not the tidal force, it is not the gravitational force, it is the convectional current that are generated in the hinted interior of the earth. Getting it? So Andes and Rockies को This is the Pacific Ocean. Andes and Rockies को it cannot explain geosyncline theory because it is very wide. What explains? जहाँ जहाँ convergence हो रहा है there is folding. So this will be Japan, New Zealand, eastern coast of Asia, पूरा mountainous है, and this will be Andes or Rockies, जहाँ जहाँ collision हो रहा है. Understanding? Everyone? जिनको नहीं समझ में आ रहा है, wait, we will do all these things. इसके लिए थोड़ा GS का knowledge, those who are studying for the first time, they will may find it difficult, fine? But convection current theory समझ में आई है? Everyone, heat inside the earth. So अगर पूछते हैं तो short note के लिए, so मैं इतना बड़ा नहीं लिखाऊंगा. Arthur Holmes gave his theory in 1928. Give his theory in 1928 to explain the driving force for mountain building, as well as movement of the land, movement of the continents. Don't use plates क्योंकि plates तो इसके बाद आया concept. Mechanism of the theory. Mechanism of the theory. Point number 1, convective currents. Convective currents. हमेशा याद रखना, convection मतलब vertical rise of anything that is heated. Right? Convective currents are generated deep inside the mantle. Are generated inside the mantle. You can write deep or don't write deep. Due to radioactive decay. Due to radioactive decay. Radioactive decay of elements in the rocks. Of elements in the rocks. If you remember, interior of the earth में temperature में भी हमने ये लिखा था, initially the temperature increases suddenly because there are presence of radioactive elements, radioactive decay inside the of the rocks, causing very high temperature, causing very high temperature. Full stop. This causes the development of convectional currents. This causes the development of convectional currents. Causes the development of convectional currents. Which start rising upwards. Which starts rising upwards. It starts rising upwards. The convectional currents when they reach the crust, diverge in different directions. Diverge in different directions. डाइवर्ज हो जाएंगे. क्या करेगा वो? क्रस्ट को खींचेगा. खींचने से रबर बैंड की थिकनेस कम हो जाएगी. सो वेट खींचने से समंदर बन जाएंगे. गेटिंग इट? रिमेंबर एवरीथिंग हियर, Mountains, Mount Everest is just like a wrinkle on the surface of the earth. Sea is just like a rubber band जो खींचा हुआ है, because ये सब क्रस्ट के फीचर्स है. क्या है डेप्थ ऑफ द सी? 6 किलोमीटर्स. व्हाट इज द हाइट ऑफ द माउंट एवरेस्ट? 8 किलोमीटर्स. ये सब में wrinkles, झुरियाँ wrinkles से लगेंगे if you consider the entire diameter of the earth, right? 12,000 kilometers. Radius is 6,400. Diameter is 12,800. So it is nothing, right? So where did what was the last word? Stretching the crust, creating seas and oceans, Full stop. Oceanic crust being thin, oceanic crust being thin, is easily broken, ब्रैकेट में लिखना. इसने नहीं बताया, इसने सिर्फ इतना कहा कि इजीली ब्रोकन. ब्रैकेट में अंडरस्टैंडिंग के लिए लिखना देयरफॉर सी फ्लोर स्प्रेडिंग. हमेशा सी फ्लोर स्प्रेड होता है, कभी कॉन्टिनेंट स्प्रेड नहीं होता. देयरफॉर सी फ्लोर स्प्रेडिंग. फिर we are not going to write his theory, but I am telling you his theory. He was not concerned with plate tectonics. तब तक तो plate tectonics की आइडिया नहीं थी. He was concerned, he told ऐसे बनते हैं geosyncline. Then he said this is how Tethys Sea was formed. Getting it? Stretching से Tethys Sea was formed between the Pangaea and the Gondwana. अब if you ask me, but Tethys Sea से पहले तो there was single continent. Continent कैसे टूट गया? उसकी theory में है कि the convective currents which originate below the continents are more stronger than below the oceans. But हमें इन सब से लेना देना ही नहीं. हम तो ये सिर्फ प्लेट टेक्टोनिक्स पढ़ने के लिए ये थियरी लिख रहे हैं. हम उसको थियरी पढ़ना ही नहीं है हमें. Fine? It is not in our syllabus. Full stop. According to Holmes, the crust in the equatorial regions was stretched and ruptured. Ruptured means broken. क्यों? Due to convectional currents. Was stretched and ruptured. Resulting into opening up of the Tethys Sea. Next point. Wherever the convectional currents converge, convergent boundary forms, causing formation of mountains, due to folding of crustal blocks. Due to the folding of crust. Full stop. That is his convectional current theory. So he says, initially there is a continent के नीचे there is a convectional current. Continuous convectional current causes stretching होने के कारण the continent is broken and उसके बाद नीचे का सीमा is exposed. फिर सीमा को तोड़ना बहुत आसान है because it is less in thickness, और ऐसे it will be stretched resulting into formation of oceans etc. So this is a region of a sea floor spreading. जहाँ जहाँ convectional currents originating below the CMA and CL, that is oceanic crust and the continental crust converge, वहाँ पे folding होगी and there will be collision होगा, folding होगी and there will be formation of fold mountains. Fine? यही सब plate tectonics ने कहा है. So that is why plate tectonics theory में we don't do any thinker, because it is not at all an original theory. It is just a collection of all the relevant facts of the other parts. Fine? So we'll meet tomorrow then. You check your mail for the exact timing, and यहाँ तक का syllabus till today will be for the first test. I can take it on Sunday or Monday. If Monday after the class, if you don't have any other class after the 1 घंटे की test है, ज़्यादा नहीं, after the class, so that you don't have to specially come.